All right, so number 9, we have a concave down, so we're going to have a maximum value. The domain is all reals, and the y-intercept is -8. Okay, because that's the c value right here. Whoops. Right here, the c value. So it's going to be 0, -8. Okay, we're going to look for the vertex. So it's going to be x equals -b, so -8 over 2 times a. So that's going to give you -8 over -4, so that's going to be +2. And then for the y, replace the x's with the +2, so that's -2, 2 squared plus 8 times 2 minus 8, so that gives you 4, -8, plus 16 minus 8. Okay, so that gives you 0. Okay, so 2, 0. And it concaves down, so we know the maximum value is 0. The range goes from -infinity to 0. And the x-intercept, because the vertex is on the axis, it's one and the same. So we're going to graph this. 2, 0. Okay, and then 0, -8, so 0, 4, 2, 4, 6, 8 right here. So that means 4, -8 is also on the graph. Okay, and that's pretty much all you need. I mean, you could, if you want to, plug in a 1 if you like, but it's not really necessary. So just connect to like that. Okay, and there's a parabola. Number 10, the parabola concaves up, so it has a minimum value. The domain is all reals, and the y-intercept is 0, 10. Okay, so let's find the vertex. The vertex is x equals -b, so it's actually +8 because negative. Alright, so the vertex for this one is -b over 2a, so that would be +8 over 2 times 2, which is 4. So that gives you 2, and then replace all the x's with 2's, so that's 2 squared minus 8 times 2 plus 10. So that's 4, 8 minus 16 plus 10. So that's 18 minus 16, so that gives you 2. So the vertex is 2, 2. Now, so that gives me the minimum value of 2 and the range from 2 to infinity. As for the x-intercepts, notice that the vertex is at 2, 2, so it's right here, and it opens up. So it's never going to touch the x-axis, so this would be none. Okay, 0, 10, that would be right here. So then that means that at 4, it's also going to be at 10. So right there. Okay, so just connect your graph, your points, and there's a graph. Okay, so for number 11, it concaves up because a is positive, so it's going to have a minimum value. The domain is all reals, and the y-intercept, because of the c value, the y-intercept is 2, so it's 0, 2. Okay, we find the vertex next after this, so that's going to be x equals -b divided by -b over 2a, so that's 2 times 2. That's 4, so that's going to give me -2. The y value is 2 times -2 squared plus 8 times -2 plus 2, so that's going to give me +8, sorry. +8 minus 16 plus 2, so that's 10 minus 16. That's going to be negative 4. Okay? Sorry, negative 6. Not thinking straight. Negative 6. So my vertex is negative 2, negative 6. So my minimum value is negative 6. And the range is from negative 6 to infinity. For the x-intercepts, it is going to have some because negative 2, negative 6 is right here well, it's off the chart, right? Because I'm counting by ones on this one. So it's going to be about here, negative 2, negative 6. And it's opening up, it's concave up. So it is going to cross the x-axis. So to get the exact value for those, it doesn't factor, so you'd have to use a quadratic formula. Okay, so remember the quadratic formula, I'll write it up here on the top. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'll show the work on the bottom. Now I can factor out the 2 to make the number smaller. See how the 2 is a factor of each of the terms. So I would end up with 2 times x squared plus 4x plus 1. And then since we're setting it equal to 0, I can divide by 2. And that's how you get rid of the 2. 0 divided by 2 is 0, so that's still 0. So then x is, I'm solving for x for the x-intercepts, negative b, so that's negative 4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, so that's 4 times 1, that's 4, all over 2a. 2 times 1 is 2. 16 minus 4 is 12, so it's negative 4 plus or minus the square root of 12 divided by 2. So remember how you try to simplify radicals by taking out any squares, any square factors. So 12 has a square factor of 4. So it's 4 times 3. So I take out the 4 as negative 4 plus or minus 2 radical 3 divided by 2. And I can divide all my terms, the 3 terms, by 2. I'll just write it on the side and I'll just erase it afterwards to make it a little bit bigger. I'll just put it here on this side. So I can factor out a 2 from everything. So let me factor it out like this. So then that's going to be negative 2 plus or minus the square root of 3, all divided by 2. So this 2 and this 2 become 1. So this is my x-intercept. So I'm going to write negative 2 plus or minus the square root of 3, comma 0. And remember, just like there was another problem similar to this where we had radicals, one or two other problems, that the two intercepts are here, negative 2 plus radical 3 and negative 2 minus radical 3. So you're going to have a decimal as an intercept, a non-terminating decimal. So this is just when you change it to a decimal, it's just an approximation. So let's plot what we have. We have the vertex negative 2, negative 6. We have 0, 2 as the y-intercept. And since we know that there's symmetry here, we're at negative 4, it goes up to 2. And so connect the points. It's very thin. It's going to be something like this. Okay, and that's a parabola. Number 12, let me erase this right here. Oops. Okay, so we have number 12. It concaves down, so we have a maximum, and then the domain is all reals, and the y-intercept is 0, negative 5. Okay, the vertex x equals negative b, so that's positive 12, over 2 times a, that's 2 times negative 3, so that's negative 6. So then the x value, 12 divided by negative 6, is negative 2. And so for y, we have negative 3 times negative 2 squared minus 12 times negative 2 minus 5. So that gives me 4 times negative 3, that's negative 12, plus 24 minus 5. So that's 12 minus 5, so that gives you 7. Okay, so the vertex is negative 2, 7. So the maximum value is 7. The range, it concaves down, so the range is negative infinity to 7. Okay, now this one doesn't factor either. Okay, so we have to use a quadratic formula to find the x-intercepts. Right now with what we have the vertex at negative 2, 7, and I know it's very, very blurry, but 2, 4, 6, 7, it's about right here. Negative 2, 7. Every number that you could barely see, that's just, it's counting by 2's, right? So 2, 4, 6, 7 up there. And then the y-intercept is 0, negative 5, so 2, 4, 5 right here. And because of symmetry, we know that at negative 4, negative 5, there we have the other point. Okay, so it's going to be approximately right here. And that's basically all you need to graph this quadratic. So we just go here and here, oops, like that. To get the x-intercepts, which are right here, to get these values, we have to use a quadratic formula. So we do, and then we can't factor anything out, so nothing simplifies out like we did on number 11. So because we have negative 3 for A, negative 12 for B, and negative 5 for C. So then we have x equals negative B, so that's going to be 12, because it's the opposite of B, so that's 12, plus or minus the square root of B squared, so that's going to be negative 12 times negative 12, so that's 144, minus 4 times A times C. Okay, so 4 times A times C, that's negative 60, all over 2 times A, which is 2 times negative 3, which is negative 6. Okay, so then we have 84, right, inside the radical. So 12 plus or minus the square root of 84 divided by negative 6. The only square number that comes out is 4, because it's 4 times 21. So the 4 comes out as a 2, so we have 12 plus or minus 2 radical 21 divided by negative 6. I can factor out a negative, I can factor out a 2 out of all the terms, divided by negative 3. So, sorry, negative 6. So then the 2 and the 6 reduce like this. And so my y-intercept is going to be 6 plus or minus square root of 21 divided by negative 3, comma 0. And that's my two x-intercepts.